Are these two functions the same? I was arguing with my friend and I need a definite answer. And then there's also a second part to this question. Are there any two different functions that have the same derivative and integral? Okay, let's answer this right here first. Are they the same? I will tell you right away, yes, they are the same. Even though they look different, or this one looks more complicated, but they are the same. So the first one is f of x is equal to x, and then the second one have this piecewise function. The best way for me to show you that they are exactly the same, well, what they are the same, I wouldn't say exactly the same, because this looks different in terms of the expression, but they have the same graph. That's the key. If you take a look at this, when we have f of x is equal to x, the graph of it is just going to be the diagonal line like this. So this is y equals f of x. Well, we're done. Now, when x is 1, the output is 1. When x is 17, the output is 17, etc. Let's see how we are going to graph this. G of x is equal to x, but under the condition that when x is not equal to 100, so I'm going to do this one right here first. Still, pretty much the same thing, but we will have to respect this condition. We will have to go to when x is equal to 100, go up to the graph, erase it, and then put a closed circle to show that it's not there. And the y value of the open circle is also 100. Yeah, because 100, 100. Now the interesting thing is that if you look at the second part right here, when x is equal to 100, please assign the y value 100 there. So what it means is that when x is 100, you have to go to the y value 100 and give it a closed circle. It's like filling the hole. So in fact, with that, this and that are identical in this function sense. The key is this and that are equal point by point. So these two functions are indeed equal. And by the way, even though the picture looks different, but mathematically speaking, you're not supposed to see the open circle or any point. You're not supposed to see this. It's just that I had to make it big so we can see it. Okay, so this is really the same as that. Now, the second part of the question is that, do we have two different functions that have the same derivative or integrals? Let's take a look on that real quick. Now, let's answer the question, can we have two different functions, but they have the same derivative? And the answer for this is yes. Here's an example. So I can have the first function, let's say we have x squared. And the second function, g of x, let's say x squared plus 1. Have a look. They are of course different because this right here is just one more than that, so they are different functions. However, if you differentiate f, you get 2x. If you differentiate g, this right here gives you 2x, but the derivative of plus 1 is equal to 0. In fact, when you have two different functions, if they are just a matter of different by a constant, yeah, just 0. So in fact, when you have two different, so as you can see, f and g are different, but their derivatives are actually equal. And the reason that this works is because, in fact, they are just off by a constant, right? You see, g of x is just like plus 1 compared to that. Whenever two functions are just off by a constant, then their derivative will be equal.